Hello everyone. Today we will look into finding the greatest common factor and factoring out the greatest common factor. The greatest common factor is the highest term that divides the polynomial, divides every term in the polynomials evenly. Our steps for factoring a polynomial is finding the GCF first, greatest common factor, then divide each term by the greatest common factor. We're going to write the result as a distribution. We're actually done at step 3. If you want to check your work to see if it's correct, you can do distribution back again to check your work. Let's see a couple examples. If I am trying to find the greatest common factor of two monomials, I'll try to see if there are any common numbers that divides both of them, and if there are any common variables that divides both of them. Both 14 and 21 can be divided by 7. So I can say greatest common factor of 14x and 21y is 7. In some examples, you will see variables being common as well. On our next one, I can see that number 7 is common on both of them. I know that 7 can divide evenly. I also know that they both share at least an x that's common. Although the first term has x squared, second term only has an x, so they both share at least one x as common. And for this one, I can say greatest common factor of two terms, let's list the terms, 14x squared and 21xy squared is 7x. This is how we can find the greatest common factor of two monomials. Here's your U-try. Identify your greatest common factor and write your result as greatest common factor of 18 x to the 7 and 27 x squared y is your result. Now let's look at factoring out the greatest common factor in a polynomial. I put the steps back in here so you can look back at your notes on the top of your page. You're going to first find the greatest common factor. Greatest common factor between the two is 5x. 5x can divide this one evenly, can divide 20x squared evenly as well. We are going to now divide each term by the greatest common factor, 5x. Once we divide each term by 5x, we are going to write the result as a distribution. Because this is a common term, 5x is common on both of the terms, we are going to divide it out, and then we are going to write our result as 5x to the front, and then we are going to write rest of our problem in distribution format. If I divide 5x by 5x, from the first term we will only have 1 left. If we divide out 5x from another 5x, we are only going to have 1 left. That's what's happening here. On our next part, we have negative 20 divided by 5 is negative 4. X squared divided by x is x. So from the second part of the term, after division, we got this. We can close parenthesis, and this is our final answer in distribution form. We have 5x times 1 minus 4x. In order to check to see if my work is correct, I can do a check step. 5x 1 minus 4x. Once we do the distribution on here, we should get back to the same result. 5x times 1 is 5x. 5x times negative 4x is negative 20x squared. So we did find the same initial answer. Factoring out is the reverse of the distribution step, distributive property. So we will find the greatest common factor and then divide out the greatest common factor, right, as the greatest common factor times whatever is left after doing the division step. Here's your U try. Identify your greatest common factor. Divide out that greatest common factor from each term and write your result as multiplication. Be sure to do your check step as well. Here's something a little more complicated. We have a trinomial. This is a third degree trinomial. We can call it a cubic trinomial. In this cubic trinomial, we can factor out the greatest common factor. Let's determine what number and which variable will divide evenly in every single term. 15, 45, and 60. They all have a common divisor, a common number that can divide all of them is 15. So I know I can divide out the 15 on each of them, because 45 divided by 15 is 3, 60 divided by 15 is 4. We also can see that x, at least, and one x is common on every single one. At least one x is common. We are trying to find the greatest common factor. 15 is the greatest common number, x is the greatest common variable. So 15x is our greatest common factor. Now we are going to write our result as distribution, and here is our 15x greatest common factor factored out. Once we factor out, meaning we divide out 15x from every single term. If I divide out 15 by 15, that's 1. If I divide out an x from an x cubed, that's going to be x squared. So from the first term, we have 1 x squared. Since we divide 15 by 15, that's 1, and x cubed divided by x is x squared. Here's a quick reminder. If we were to remember the exponent unit, we had 15x cubed divided by 15x. We know that these could simplify, and we will, that's one time, and for the exponents you would subtract the exponents one from another during division. So 3 minus 1 is 2, so we know the result will be x to the second power. That's how I got my x to the second power here. Let's continue our next term. 45 divided by 15, that positive 45 divided by positive 15 is positive 3. X squared divided by x is 1x. Negative 60 divided by positive 15 is negative 4. X divided by x is 1. And here's close parenthesis, and we are done writing our answer. We can also do a quick check step. Here's my quick check step. Please get used to doing check steps. If we are to distribute our result back to inside of the parenthesis correctly, we should get back to the original expression, original polynomial. Here is 15 times x squared is still 15. X times x squared makes x to the third power. 15 times 3 is 45, positive that is. And x times x is x to the second power. 15 times negative 4 is negative 60, and x. And it does give us the original result, so we know that our factoring out was correct. Again, just to remember our steps, first find your greatest common factor, and then divide each term by the greatest common factor. Write the result as a distribution. We can do a check step by distributing. Here is your U try. Identify your common number and common variable for each term. Factor out, write your result as distribution. Check your work by distributing back in. That's pretty much it. If you have any questions, please make sure to bring them to the class.